Okay, I'm going to do an example problem for you guys here. In your problem set this week, you had to do number 33 on page 110. So you're helping to repair a roof by loading equipment into a bucket that workers hoist to the rooftop. If the rope is guaranteed not to break as long as tension does not exceed 450 newtons, and you fill the bucket until it has a mass of 42 kilograms, what's the greatest acceleration that the workers can give the bucket as they pull it to the roof? So let's write down what we know in this problem to start with. We know that the maximum tension that the rope can withstand is 450 newtons, and we know that the mass of the objects in the bucket is 42 kilograms. So a great place to start on these problems is to draw a free body diagram. So I calculated the weight force here. I took the mass of the stuff in the bucket, 42 kilograms times 9.8, and found that the weight was 411.6 newtons. So I'm going to write that in on my free body diagram here. So this is a diagram of the bucket. And then my tension force is going to be 450 newtons. That's basically the strength of the rope. And how do we find out the acceleration of the bucket? So what you do is you're going to write an expression to figure out the net force, kind of like this. So the tension minus the weight is going to be equal to the object's mass times the maximum acceleration. So the tension up here is going to be 450 newtons. The weight is going to be 411. And basically the difference between those two is going to tell us what the net force could possibly be here. And then we'll set that net force equal to the mass times the acceleration. We know the mass, and we'll solve for the acceleration. So the net force in this case is 38.4 newtons, and that's up. And we set that equal to 42a. My max acceleration that I could have in this physical situation is 0.91 meters per second squared. If I accelerate more than that, that's going to make the tension force bigger, which will break the rope. Hopefully that helps on that problem. But while I've got you here, I'm going to do one other thing. I want to talk about a case where we use Newton's third law to solve kind of a complex problem. So let's say, different scenario, I have 3 blocks. And those 3 blocks are resting on a surface, and the blocks have masses 3 kilograms, 2 kilograms, and 1 kilogram. And we apply a force to the block number 3 of 10 newtons. And our question in this case, disregarding any frictional forces, is what is the force by block 2 on block 1? Okay. So take a moment and think about how you would approach this problem. This is going to be an application of Newton's third law. So step 1, your strategy for multiple block systems is to treat the 3 blocks as they're just 1 block. If that's the case, really this looks like this: a 10 Newton force pushing a 6 Newton block, or 6 kilogram block, sorry. And if that's the case, we can find out the acceleration of that block pretty easily. We'll go force equals mass times acceleration. In this case it's the net force because there's no opposing forces. So we would say 10 newtons is equal to 6 kilograms times the acceleration. So 10 divided by 6 is going to be the magnitude of the acceleration, which is 1.66 meters per second squared. So how do I go and find this force? Is it just 10 newtons? The answer is no. We're going to have to draw some free body diagrams to solve this one. So first let's draw a diagram on block number 3. Block number 3 experiences the 10 Newton force. It's going to have a force back in this direction by block 2 on block 3. We're not sure about that force yet. So this is the free body diagram of block number 3. The free body diagram of block number 2 would look like this. Block 2, there's two things touching it. There's a force by block 3 on block 2, and there's a force back by block 1 on block 2. This one has to be bigger than this one. Why? Because they're all accelerating at the same rate of 1.6. And then the diagram for block number 3 would look like this. There would just be the force by block 2 on block 1. Sorry, this is a diagram of block 1. And we're trying to find in this problem the force by 2 on 1. This guy right here. But that force is also present here on the free body diagram of block 2 because these are a third law force pair. So I don't actually have to look at this diagram. I can focus here. But I don't know what that force is. That's what we're trying to find. The key is here we have to figure out what the force by block 3 on block 2 is first. And I can do that by looking at free body diagram number 3, because these two are a third law force pair. Opposite direction, flip the subscripts, same magnitude. So block number 3 is really the key to what's going on. We're going to say that the net force on block 3 is equal to 10 newtons minus the force by 2 on 3. And that is going to equal the mass of block 3, which happens to be 3 kilograms, multiplied by its acceleration of 1.6. So now I'm treating each block independently instead of treating them as a system like I did in the beginning of this. So 3 times 1.66 is going to give me 4.98. That's going to be the magnitude of the net force. So 10 minus the force by 2 on 3 is going to give me 4.98. So the force by 2 on 3 is 5.02. I can write that here in the free body diagram, 5.02 newtons back to the left. I can also write it on the free body diagram here, 5.02 of block number 2. So I identified the force by 2 on 3 by using an expression for second law, finding the net force and set it equal to mass times acceleration for block 3. Block 2, I can now analyze to figure out the force by 1 on 2, which is the same as the force by 2 on 1, which is our goal. Remember, we're trying to find the force by 2 on 1. Okay? So we're going to use the same approach here. We're going to say the net force on block 2 in this case is going to equal the force by 3 on 2 minus the force by 1 on 2. And that's going to equal the mass of block 2 times the acceleration. So let's write in what we know here. We know the force by 2 on 3 was 5.02, and therefore the force by 3 on 2 has to be the same. So 5.02 newtons minus the force by 1 on 2 equals the mass of 2, which is 2 kilograms, times 1.66. So 2 times 1.66 gives me 3.32 as my net force. What that means is 5.02 minus this unknown force gives me a net force of 3.32. So 5.02, solve for that. Okay, so I did that. My answer here, the force by 1 on 2, turns out to be 1.7 newtons. So let's look back here at the what's going on. In the beginning of this question, I asked you, what is the magnitude of the force by block 2 on block 1? And we figured it out to be 1.7. So there's these third law force pairs in between each block which are less than 10 newtons. And the force pair between these guys we said was 5.02. And so let's think about why this should make sense. The forces between each of those blocks are less because we don't have to accelerate as much mass. So the 10 Newton force has to accelerate all these blocks together. The force by 3 on 2 is only having to accelerate blocks 2 and 1, and the force by 2 on 1 is really just having to accelerate block 1. And so in review, the strategy here is to take the blocks and treat them as a system, add the masses of each blocks together, and just make it one big block, find the acceleration of all the blocks, and then realize if I treat each block independently, they still have to have the same acceleration, but the forces might be different in between each of the blocks. So that's a really important application of Newton's third law to kind of analyze a complex situation. Let me know if you have any questions.